Hello everybody and welcome to our first lesson in Unit 5 on similar triangles. Today's lesson is on similar polygons, and our objective is we will be able to use ratios and proportions to write and solve equations. We will also be able to identify similar polygons and use them to find missing side lengths and angle measures. We spent an entire unit talking about congruent polygons, or particularly congruent triangles. Congruent triangles have to have the same shape and the same size. But more specifically, what does the same shape really mean? It means that the angles have to be congruent. And what does the same size mean? Same size means that the sides also have to be congruent. Now, for similar polygons, it's not quite the same. Similar polygons still have to have the same shape. So the angles also have to be congruent for similar polygons. But they have different sizes. However, the sizes cannot be just randomly different. The sides have to also be proportional. They can't just be any random lengths, and that wouldn't work anyway, because if the angles are already congruent, then sides cannot be any length that they want. If two figures are similar, we can write a similarity statement, and the similarity statement we have right here says triangle ABC is similar to triangle DEF, and here you see that little squiggly line, which is our symbol for similar. Think back and remember, for congruent polygons we used the symbol, the equal sign with a squiggly line above it, and that is because they have the same shape and the same size, so every part of those polygons has to be the same. For similar polygons it's a little different, only the shape has to be the same and the size is different. That's why for the symbol we only use the squiggly line. The similarity statement shows us that the two figures are similar. But it also shows us which parts correspond. And if we have a similarity statement, we can go ahead and also write a statement of proportionality. A proportion, in other words, that relates the corresponding part of the two similar polygons with each other. In our example, we can say that side AB, which is the side with the length that's in the middle, is corresponding to side DE. And the ratio between these two has to be the same as the ratio between the longest sides, BC over EF, and that also has to be the same as the ratio of the shortest sides, AC over DF. Now, when we use letters, that's not quite as clear. So let's look back and use the side lengths of these 6 different segments. AB is 6. 6 over 3 has to be equal to 8 over 4, which has to be equal to 4 over 2. Now we can simplify these three fractions. Right now they don't quite look the same, but if we simplify them, we get 2 over 1, which is equal to 2 over 1, which is equal to 2 over 1. And that's what we wanted to prove and wanted to see. So our statement of proportionality shows the ratios of the corresponding side lengths. So what is our scale factor? Our scale factor, which is a ratio, is in this case 2 over 1, or we could also write it with a colon, 2 over 1, and that is the ratio of the lengths of two corresponding sides. The scale factor essentially tells us how much does one of the two figures have to be stretched or shrunk to be the same size as the other one, and we also call that dilation. So we can say triangle ABC is dilated by a factor of 2 from triangle DEF, and from triangle DEF's perspective, it is dilated by a factor of 1/2 from triangle ABC. Since we're using ratios and proportions a lot in this unit, let's do a quick review of what these two concepts mean. A ratio is an expression relating to quantities. We have different ways that we can write it. It can be written as a fraction. Just to give an example, 2 over 3. It can also be written with a colon, 2 to 3, or even with the word 2. These are the three different ways that we can write a ratio. Here is an example. Write and simplify the ratio of the width to the length of the rectangle. Now in the rectangle, either side can really be the width or the length, but very often we make the shorter side the width and the longer side the length. So let us just define that here. And then we can write our ratio. And remember, for the ratio, order matters. Therefore, our ratio of width to length is 8 inches over 2 feet, which we can simplify to say 4 inches over 1 foot. We could leave it like that, but since we have two different units, it may be a little confusing. So let's replace our foot measure by what it's equal to, which is 12 inches. So then we can write 4 inches over 12 inches, and then we don't even need the unit anymore. We can simplify it. We get 1 over 3, or as we said, we could also say 1, 2, 3 using a colon or even the word 2. A proportion is an equation relating two ratios. If I use letters, I can write it like this. A over B is equal to C over D. And the way we solve a proportion equation is by using the cross product property. You may have heard this called before cross multiplying. So a proportion A over B is equal to C over D gets solved by multiplying across the equal sign, and then we multiply A times D, which is equal to B times C. Now we have a few examples that I would like you to try yourselves. So go ahead and stop the video, do the work yourselves, and compare your work with my answer afterwards. One word of caution before you start. If you have two terms in numerator or denominator of any of the ratios, go ahead and put parentheses around them, and don't forget to distribute when you cross multiply. Hopefully you have arrived at the same answers. In our first example, we get 5y is equal to 150. Divide both sides by 5, and y is equal to 30. In our second example, we start off with 300 times the quantity of y plus 2 is equal to 500y. Distribute the 300, we get 300y plus 600 is equal to 500y. Now we subtract 300y from both sides, and we get 600 is equal to 200y. Divide both sides of the equation by 200, and we get 3 is equal to y. In our third example, we also have to distribute. We start off with 2 times the quantity of y plus 6 is equal to 42. Distributing 2, we get 2y plus 12 is equal to 42. Now we subtract 12 to get 2y is equal to 30. Divide by 2, and y is equal to 15. So much for now, and now go ahead and watch the second part of this tutorial.